Thank you, everyone. Audio good? All right, I walk around a lot, so I'm going with a lav mic instead of the podium. And plus, it would be really awkward to stretch that thing up for me. So let me tell you a little bit, first of all, about MIMO and what we do. Our objective is to help manufacturing and operations firms find the shortest path from data impact using machine intelligence. Machine intelligence is essentially the combination of AI and machine learning, so you can choose which term you like, but usually AI sets expectations too high, machine learning sets expectations too low, so we pick something right in the middle. What we do with MIMO is it's really a research, education, and collaboration effort designed, as I said, to transform operations and manufacturing with machine intelligence. And we actually work very closely and are sponsored by the Leaders for Global Operations. I see several of the students and alumni here, and that's a fantastic program. And we really help then focus some of those students, and then also PhD level research in manufacturing and operations. So I'll start first with the research piece, one of which I'll go in deep dive today, but we do on campus and in the field PhD level research of applied AI, applied machine learning in manufacturing and operations. We also do educational programs like this. We run a deep learning workshop. We're running a symposium on May the 4th, which I will advertise and talk about later. We hope you guys all come. But we also educate the research sponsors on what we're doing and why in our machine learning method. And then lastly, collaboration. Machine learning in manufacturing is typically a lonely place. There aren't a lot of people at any one individual company, so we help them work together through things like the symposium. We have a weekly student research forum with PhD students here at MIT, but we bring in industry players and data scientists as well. So let me talk about the research that was just published last week in Harvard Business Review. It's a collaboration with McKinsey and MIMO. And we set out to really look at the state of machine learning in manufacturing operations, what worked, what didn't work, a really on-the-ground view. Because what we found is talking to a lot of companies, they've gone through this big data era. They've collected a lot of data. They don't know if it's valuable. They aren't able to use it. They don't really know where to start because it's a very complex field. So we looked at their struggles and did some literature research, and you quickly see why, because a lot of the literature tells you if you're best, how do you become better, right? So you're already an A player, how to be an A+ player. Most people are in this particular area just getting started, or it's just a lot of anecdotal bits here and there that are very difficult to put together. So we decided to try to help develop a roadmap that can tell you where you should go next, and like any good roadmap, you need to position where you are. So we give people situational awareness on self-assessment where you are, then a roadmap of where you can go, and a playbook for kind of best practices to use along the way. So today, we'll talk a little bit about the scope and impact of the effort. We'll highlight what the leaders do, and then the other three categories as well, what they do well, what we can learn from them. We'll talk about the implementation playbook that I mentioned. We can't really get into it in too much detail in the time we have. And then lay out a kind of next steps journey for you on how you can keep moving, because that's really our goal, is to help you use this transformational technology. And a good number to take away with you is leaders, which are about 15% of the group that we studied, get twice the KPI, the key performance indicator improvement, twice the KPI improvement using machine learning that kind of the rest of the group gets, and they get it in half the time. So we've got a structure of roughly exactly nine types of things that leaders do, or all companies do them, but the leaders twice the result in half the time. And you look at that compounded year over year, and that's where your disruption is coming from. In this case, the disruption is not a Clayton Christensen innovator's dilemma coming up from the bottom. It is typically, but not always, the larger companies really applying machine learning technologies at scale broadly across the organization, and that's giving them truly a sustainable competitive advantage that they will carry year over year. And you can see it based on their investment strategy that we'll get into. So this is and it's a lot of data. So if you go to the first URL, mimo.mit.edu, you can find links to several articles that have been written that cover a lot of this data for you. So the first thing, KPI improvement, on average, it's actually 3x. If you looked at all the different KPIs, so 9.5 versus 3.5, and we'll go through the different KPIs. We looked at 21 different ones. Don't worry, I'm not going to walk through all of them, but you get the general idea. We looked at these 9 categories of enablers I mentioned. We looked at 17 different desired business outcomes, and then 17 different use cases. And in just a minute, I'll go across the industries that we looked at. And we really were able to group things into 3 different sets. The results, and by results, I'm talking broadly. So KPI improvement, payback period, what types of use cases did they do, and how did they scale them across the organization. Then the enablers. So enablers are things like, what type of people did you hire? What kind of training did you do? Who did you train? How much data did you collect? Who did you give access to that data? Did you share data with partners? And then deployment. How long have you been at it? And then how many functions, how many use cases, and across how many divisions, and then also, to a certain extent, the efficacy of your work. So there were really 5 things that stood out of the 9 enablers that I talked about, and we'll get into those in more detail. And then the final, what we'll close with, is the fact that leaders not only are getting better results, they're investing more on average, and they will invest year over year more on average. So not only are they leading, they will continue to lead more in the future because they're getting results. So first of all, I think the question comes up, what is machine intelligence? Broad is certainly what is AI. Well, I won't even ask that question. So we look at it from really insight at the bottom all the way to autonomy. So, at the bottom of this chart, this is what most of you have and see. Oh, let me mention one more thing about this study. Who participated in this study? So we sent it out to actually very leading companies already. So we sent it to the whole ILP list. We're all invited to participate. We sent this out to the LGO program I mentioned. So that's 1,400 alum over the last 30 years. And those are students that have gotten a master's in engineering and a master's in business here at Sloan, and were hand selected because they really want to change manufacturing. So then they've gone in their careers. And then lastly, the entire McKinsey alumni base. So, a fairly good base to choose from. So there's a lot of selection bias toward the higher end, even to start with on this particular study. So digital reports and dashboards, where most people are, descriptive analytics. So if you hire a data analyst, they will tell you kind of what happened. Then you move up into predictive analytics, what will happen. Prescriptive, what can I do about what is going to happen? And then at the highest end, you have machine intelligence, where you're learning from data, the machines are learning from data, and they are making adjustments, typically autonomously. So real-time control systems, we'll go through a couple examples. So as far as respondents, so it's roughly 100 companies, almost 200 respondents. So on the right-hand side, you have the size of the company. So it's not all big companies, but the left-hand side obviously are quite large companies, so roughly half. But then you look at the right-hand side of that donut over here, and you see the companies are actually fairly small. So, and then a broad range of industries from retail, healthcare, CPG, aero and defense, automotive, kind of what I'd say the usual suspects. Okay, nice eye chart for you here. This is the KPI improvements. Like I said, this is all available online. The best way to read this is to look at, say, I was afraid I would do this. I'd go for the laser pointer and hit the button. This is what leaders are doing. So they're getting a roughly 16% improvement in factory efficiency versus the rest at about 16%. So some examples that we talk about here, we'll take equipment efficiency, a company called Vistra. They are an energy producer. They produce power for about 20 million homes. And they wanted to optimize their factory for what's called heat rate. So the amount of essentially either natural gas or coal that comes in, then how much actual energy comes out. And running that system optimally, actually in this case it was a coal-fired plant, running it optimally means I need to look obviously at the load. I can adjust things like the rate that the coal comes in, the blower speeds, the pressures of the tanks, the flow rates of the water in, and there's roughly 100 variables. And so they were able to optimize those variables and get about a 1% savings. Now that doesn't sound like a lot, but when you realize if they scaled that one plant across all their facilities, that's about 200,000 homes worth of energy every day that they get just from looking at using machine intelligence. So that would be one example. Labor efficiency, we did a project at Analog Devices, actually did this through MIMO, and a couple of them. So the one at Analog Devices were actually, I won't get into the technical detail on that, but essentially we're able to determine which lots of product might be bad and which aren't. So instead of a process engineer needing to look at all the different process runs, we narrowed it down to about 5%. And it's a non-Gaussian process, so it's actually kind of hard to figure that out. You think, oh, I could just use statistical process control, but that doesn't work at all in this particular case. In fact, standard statistical process control is a worse predictor than flipping a coin. So it's like, okay, that doesn't really work in this particular case. Let's see, we could come down here, transportation and logistics, Wayfair, especially in the pandemic. Who uses Wayfair? Somebody updated your crib, they bought some new things. They needed to optimize which port ships came in based on the surcharges that were being charged at any particular port at any given time, and then where all the things that were on that ship actually needed to go within the country. And that was a continual ebb and flow, especially with all the port blockages. So they saved about 7.5% on their logistics costs by optimizing. So another Wayfair example, demand accuracy down here. What they were able to do is the call center, the demand of people calling up and just asking questions about the product. So they were able to essentially reduce their costs overall by about 20% by having the right people at the call center at the right time, having them available, rather than, sometimes you would call up and no one would be there to answer the phone, and other times people would just be sitting around. So then that also impacted, their service level, because now fewer people were waiting on the phone. So those are just some examples where you could take these data sets and apply machine learning algorithms and get gains from them. So you saw the leaders versus the rest. How did we determine what the leaders were? So what we did is we looked first at the results down here, and these are compound metrics, but we looked at how much impact they achieved in terms of use cases, KPI improvements, payback periods, et cetera. Then we looked at the enablers. So what things did you do? How much did you spend? What kind of people did you hire? Who did you train? What data did you collect? Who did you let see the data, et cetera? And then we clustered it. So in this case, we used k-means clustering, and this is the result that came out. There are exactly 4 clusters for those of you who know what k-means is. And what we ended up calling these are leaders. That was pretty obvious up here. So they get the best results, and they have done most of the right things. You have down here on this side what we would call the emerging. So these people are just getting started. Then you've got these 2 groups in the middle. These are what we call the executors. So what they do is they haven't done as much of the enablement, invested in those kinds of things, but yet they're still getting pretty good results. So they've really focused, and we can go a little more in detail on what they've done, but they've focused on choosing problems that were important to them and making sure they had the data, and typically partnering with a vendor or someone to then just get results quickly and focus on that. A good example of that, of a executor would be a company called Bayer Pharmaceuticals. They use a governance process to pick one application that works really well for them and then rapidly deploy it around the world. So in many cases, you'd think they're a leader, but because they executed so well, and they spent so little, they actually end up being right in there as an executor. So it is possible to just really supercharge your results and your KPI in that way. And then just the relative size of the bubbles here is how many implementations they've done. So we end up with these 4 clusters and these 9 areas, and there were really 5 of them that mattered the most. But I'll tell you a little bit of how to read this chart, and like I said, all the documentation online will help. But so let's just say that you're an emerging company. And so these gray bars, this is what the bottom half of the grouping is doing. So if you're in a gray bar, that means you're the bottom half. If you're the dark blue bar, that means you're in the top quartile. And then light blue is that middle quartile, the second quartile. And if you're an emerging company, you see that they're kind of in that middle quartile on 3 things and nothing else. So what are those 3 things? They do well in partnering, data execution, and results. So if you were just starting, this would be how you'd want to start. Say, okay, I've got a problem that means something to me. I make sure I have the data for it, and I go out and I find the best vendor to help me out. And so that's how they've started this. As you move up the line, you would say, okay, let's look at what executors are doing well. So what executors have done, once again, still focusing on results, but they found the problems that are solvable in the industry today through vendors and just general, they're just more solvable. We can get into a little bit of what they are. Planners move one step up. They tend to hire more people, put a data infrastructure in place, and then leaders are obviously firing on all the cylinders because they're able to get these outsized results. But now, they've set this as a corporate strategy. They have a governance process in place where they actually look at process improvements. They track it and they monitor it at a corporate level. They do have, like I said, aggressive deployment programs. They do things like they partner aggressively. We can get in a little bit more. You would not expect leaders to do that, but they do it more than anybody else because they know they can't do it alone. People, they're hiring the right people and obviously putting data infrastructure in place. Okay, so let's just talk a little bit about this, and I'll go fairly quickly through these things. But as an example on governance, in no case does a leader not have a process. All leaders have processes. And in fact, over half of them continually refine and improve it. By contrast, many other people have no process. Maybe they've defined it, but they don't follow it, or they might follow it occasionally. Leaders do not do that, right? They have a process, and they continually follow it. This one is an important chart. Once again, I apologize, it's an eye chart, but all of this is available. What you see here is, once again, this light gray is what leaders do, and then the darker gray is the bottom 50%. Leaders very much focus on winning applications. All of them do some type of demand forecasting. All of them do some type of transportation optimization logistics. So I gave you two examples from Wayfair. A couple examples of predictive maintenance. Frito-Lay runs predictive maintenance on their line. They were able to save 1 million pounds of potato chips, basically, which is a lot of potato chips. Colgate-Palmolive does predictive analytics on their line. They were able to prevent an 8-day outage, and that was 192 million tubes of toothpaste. So those are the kinds of things and the relative importance of those three. And then, coming right in behind those are inventory optimization, early warning systems, other types of process improvement, and obviously inspection is very popular. So that's what leaders do. I think the other takeaway is it's kind of scattershot for everybody else. So one of the things that helps define leaders is they tend to work on these problems that are solvable. Okay, so this particular chart is a little bit like the optical illusion where you look at it and sometimes you see the young lady, sometimes you see the old woman. You got to stare at it for a little bit, and once you see it, you're like, oh, well, that's pretty cool. So what this is, these are the same use cases that we just showed you, and the 5 different ways of solving the problems that I told you about, starting with a dashboard all the way up to machine intelligence. And then the color of the darker the color, the higher percentage of people are using that particular method. I think it's easier to start over here with kind of the bottom 50% of the companies. And what you see is the method they use most is dashboards. And I would say that's probably not surprising to anyone. We designed this study as a longitudinal study year over year. So what we hope is to see these blue bars, darker blue bars, continue to march left to right for the leaders as they move to more and more sophisticated approaches to solve their problem. But right now you can see it's a little bit darker over here in machine intelligence, but still a lot of predictive analytics is really what's most popular right now. I mentioned partnering earlier. This I would put in the surprising category. Probably most people think that leaders do everything themselves. They think of Google or Apple or Amazon or Facebook that do everything themselves because they can. Well, in manufacturing operations, that's not the case. They do typically have a center of excellence, but they partner pretty aggressively with academia. It's a little self-serving because that's what Mimo does, is we help set up that partnership, but I promise I didn't rig this at all. And they also partner with startups. So the companies like you're seeing out here. Now, the question is why? Why do they do that? Why don't they go to the main suppliers? And the reason is that all manufacturing is different. You don't have structured data sets like you have in MRP and ERP. And what you're really looking for is domain expertise. And so if you go to academia or you go to a specific startup, they are focused on solving a very specific problem. Whereas if you buy a generic industry toolkit, it ends up typically being more expensive than what people want to pay. So that's the why you see that level of partnering. So we talked also, I mentioned hiring. So many people, when they're coming, at this field, they think, if I just hire a data scientist, my problems will be solved. And it is true, 92% of leaders have data scientists. And, it turns out a lot of the bottom 50% do the same thing. Remember, this is a sample bias, so people are already trying to do machine intelligence typically. But what you see then is these other job descriptions are coming in, like a data engineer, someone who's actually going to develop the pipeline, handle the ETL. And when you see a big spread, that really tells you what leaders are thinking about versus everybody else. So machine learning engineer, some people would call them ML ops person. So a person, the software equivalent would be the person who runs the software after somebody writes it. So, the data scientist is writing the software. The ML engineer is actually going to go run it. So this means they've moved farther along, that they actually have code they need to run. And then they've got product managers, so people who are dedicated to match the solution with an actual problem and calculate the ROI and make sure it actually gets implemented. Another big area of spread here is this one. So this is train employees, teach them what's going on. Huge spread here, line workers. So you'll see that leaders actually train their line workers. As they do train, obviously, division leaders, engineers, they train all the way down, but the big spread is training people on the floor how to use data analytics, and also from a data perspective, they give them access. So instead of data being viewed as knowledge is power and I'm going to keep it to myself, what they do is they give it out to everybody. So this particular chart is talking about the use of data. So where are you on your digital thread? So are you sharing data with your suppliers and your customers? Obviously, that's something that leaders tend to do. I'd already mentioned this one about giving employees access to frontline data. So 100% of leaders do that. And obviously with COVID, this number is going up. The number of people get remote access to data. Typically, manufacturing companies don't like to open up their data sets to the world, or specifically, open their firewalls up. But leaders do invest in that. And this is always a question that people ask is, how much data do I need to store? Well, so we kind of looked at kind of a threshold we looked at 0, 5, 10%. And 90% actually store more than 10%, and they do store it, not all of it on the cloud, but typically the data that they're going to do machine learning with does end up on the cloud so that they can use more powerful tools and they can federate it with other data. Another really important differentiator, and this would be something you want to do early on, is which data matters, right? I've talked to lots of people and they think, oh, I can't afford to collect data on every machine in my factory. That's one extreme. The other extreme is I've collected all this data over years. What can I do with it? So typically, historical data probably has some issues with it and won't be all that useful. And you definitely don't need to collect data on everything. Okay, so that is what I wanted to cover on just some of the main differences that we see, that what leaders are doing versus other people. And then this talks a little bit about budget. And so we looked at budget this year, next year, and by different functional areas. So customer service, manufacturing operations, product design, then supply chain management. Once again, the leaders are in the blue bars there. So the takeaway here is they do invest quite a bit more on average, and this is percent of spend. So, in order to normalize it, just percentage of everything they spend, how much is allocated to machine learning. So in some cases, double is what the leaders are spending. And then next year, you see roughly the bottom 50% have kind of stayed flat, but leaders are investing more. So they're already ahead significantly, and they will continue to move ahead. So we've got get some upvotes here. So let's talk about the journey. What are you going to do? What should you do next? So what we see that companies do well is, they determine where they want to be, what's important to them. This is kind of back to that governance station. Where do we want to be in 3 or 4 years? And then look at the things that can help them. And they have to manage to all the constraints, whether it's budget constraints, legacy systems, and then obviously the kind of talent they can attract. They need to look at where they stand, and that's what that matrix was all about. Of what type of category are you, or what type of person are you? Are you emerging? And then across 9 categories, and then each of those categories then has subsections to it that I didn't take you through. But get that really good self-assessment of where you are, and then start to look at a transition plan. And I walked you through a little bit of a transition plan of going from an emerging to an executor, moving. You don't really go through planner, but you do have to do some of the things that they've done, and then on to a leader. And then the last thing is, what use cases matter to you? Just because it's in vogue, just because everyone else does it, doesn't mean you should. But if they're not doing it, maybe it's not the first thing you should start with. So pick something where there's a little more research done and more tools available, but that still matters to you. And do obviously your ROI analysis, because you don't want to get caught in what's called pilot purgatory, where people just think, oh, AI or machine learning is cool, and we go do something, and it doesn't really have an ROI, even if it worked perfectly, so it just kind of sits there. So that's definitely what you want to avoid. So I told you I'd talk a little bit about the playbook that we've created. So what we do is, this is the 100 companies that filled out the study this past year. We showed them the result of that impact matrix. We then showed them how they stacked up. How did you answer? Where do you fit in that scale? And you see, this is kind of an interesting company. They're actually a leader in a lot of categories, but they're in the bottom 50% of a whole bunch of other categories. And then we go through each one of those categories. There's typically 4 or 5 different areas, and we break that down. So we show you, okay, what business outcomes were you working on versus everyone else? So your answers are there. This is what leaders are doing, and then that's what the bottom 50% are working on. So you can see, oh, well, the business outcome I'm trying to get, whether it's customer responsiveness or improved quality, obviously increased revenue or margin, other people aren't working on that. So maybe I should do something a little different, but if it's key to you, then obviously you need to keep working on it. Then this is the same thing on KPI performance. We walked through this chart already. And then this is which functional areas are you deploying in. So if you're, this is where leaders, they're doing a lot in manufacturing and engineering and planning, percentage-wise a little less in as far as overall number of implementations in design and transportation and warehousing, but obviously it's still operating there. So this is just a snapshot of a 30-page readout that is designed to help people move from wherever they are to the next better step. So, we're not, if you're here, we're not trying to get you to there. We kind of say, all right, well, here's some things you could improve on, like for next time, right? A year from now. Set that as a goal. And then it gives you typically it's pretty clear what would be the next step. So, what's next for us and what's next for you? We'll run the study again this year. We hope all of you will participate because we want to get this year-over-year tracking. We had 100 founding companies. We'd love to get more, so hopefully many of you will be that. And then also, if there's enough interest for conglomerates and companies with multiple divisions, I would love to do fingerprinting across multiple divisions or across multiple companies within a conglomerate so that they can see how all the different companies or divisions stack up and where they need to focus improvement in all those areas. So what can you do? Read the research. We have a symposium coming up on May the 4th. I'm going to throw a slide up on that in a second. Sign up to participate in the study, and then you'll get your own custom playbook and roadmap. But you do have to fill out the survey. There actually were more people that filled out part of the survey, and there just wasn't enough data there to create a complete playbook. It takes at least an hour and a half to fill it out if you have the data. Getting the data is a challenge, so there can be. You saw the types of questions. You may or may not know the answers. So here's the research, mimo.mit.edu. You see the link to our Harvard Business Review article. There's a longer form article on McKinsey, and then MIT News has a really nice article on some very cool defect inspection work. And then our symposium, it's May the 4th. It'll actually be at the ILP offices there at 1 Main Street. So thank you to the ILP. How do you maximize your data? It's really designed to help you operationalize your AI strategy. I used to be able to say that. So the goal is to help you along that journey. So how do you get value out of data? What should your strategy be? How do you change your culture? And then managing development projects. And we also have a $10,000 poster prize where students are coming in from all over MIT, so you can see the cutting edge research of application research, so applied machine learning to manufacturing and operations from MS and PhD students across the engineering programs and the engineering school. So I have 30 seconds maybe for a question. Data scientists are hard to find, especially if you're not in the Silicon Valley. Is that going to hold back companies that want to do more with MI? No, because partnering is the #1 thing across the board. Everyone from leaders to emerging are partnering with either startups or known solutions. And I didn't get into what McDonald's and other companies are doing in terms of centers of excellence. It's not true in McDonald's case, but in other companies, their centers of excellence are small, so they can pick the best partners. So they get a couple data scientists that can, figure out what's hocus pocus and what's not, and then they partner with some really awesome companies out there.
That's excellent. And Bruce, we have another 9 minutes for questions. We put your clock on at 30, so we totally screwed.
Oh, see, they knew that they would force me to go faster because I will talk longer. Okay.
I think you've answered some of these, or at least alluded to them.
Yeah.
I'm sure you'd like to expand on them. And I think the first one up there with the major difference between predictive and machine intelligence is cogent relevant.
Yeah, so there's a company called Augury, and they actually use machine intelligence to do predictive maintenance, but their data scientists are doing it. Typically, predictive analytics would use a simpler techniques like linear regression, things like that, where you're technically machine learning, but it's not that complicated. But then like a machine intelligence would be something that the work that Chris Couch is doing at Cooper Standard. So what's being done at Cooper Standard is it's a real-time process control application. So they've actually trained a machine learning algorithm, in this case a neural network, to learn the process changes in a highly complex process. So instead of using a normal PID controller, they've actually trained a machine learning controller to figure out how to manage that. One of the things, a project we're doing at MIMO for a major car manufacturer. So just to give you a little background, this company has developed a new engine technology that they put into production just in the last year. And it's also the same plant that they make motors in. So it's not like they don't know electric cars are coming, but they know that there's a long tail in gasoline engines and they need one that will be competitive for the next decade. This is the most sophisticated assembly line in all 70 plants of this particular company. They measure 8,000 variables during the production, the assembly of this particular engine. So that's everything from bearing surface finish, bearing ovality, to the actual torque profile, not the max torque when they drive a screw down, but the actual torque profile and how it changes and falls off. So they measure all of these things, and the project there is to help them determine which things relate to which. So I'm a test engineer on a factory floor, and something fails. I then spend some number of months trying to figure out which things upstream I can change that are going to fix that thing downstream. As they describe it, it takes them years, sometimes, and lots of scrap to really understand those correlations. So what we're doing is taking all of those 8,000 variables, some from tests, some from assembly, and correlating them back so that we can say, all right, when you get these types of failures, it's these things upstream that cause them. And the way the executive described it, he said, every time we have a problem, it's like looking for a needle in a haystack. What you guys are doing is blowing away all the hay and leaving me with a stack of needles. So that's that particular project. So a couple examples, hopefully that was helpful. Is there a bottom-up component? Big companies getting into ... Okay. Yeah. So the bottom-up piece is twofold. One piece is this study where we give you comparative data to see how you fare versus other people, and then give you a roadmap of, okay, I'm here, and I'm not doing these things. So here's an example, right? I've only hired data scientists. Well, it looks like leaders have data engineers, they've got data, maybe I've got data scientists and a data analyst. I don't have any data engineers, so I'm asking my data scientists, oh, well, you just go get that data and you do the ETL, you do the data pipelining for all of it. That's a whole separate skill. And your data scientists can kind of do it, but they're going to be frustrated and they're going to quit. What they want to do is solve interesting problems. So you would see in our study, it's like, oh, I don't have any of this person. Maybe I should hire them, right? And data scientists often aren't good at telling you that. So you just ignore them until they quit. And we've seen this happen. So that's an example of bottom up. The second thing is the kind of research that we do at MIMO. It's application research. I'll give you another example. For the largest desalination operator in the world, we're doing an energy efficiency. So very similar to the Vista example I gave you. Water desalination is it's a very energy intensive process. Essentially what you're doing is you take seawater, you push it through a filter, salt ends up on one side, clean water ends up on the other. That force takes a lot of electricity. So this particular company is the largest operator in the world, and they have the leading performance in the world, and by a good distance. And they've realized after doing all the physics-based models, spending hundreds of millions of dollars with every vendor, everybody they can think of, okay, let's apply machine learning now and see if we can get 1 or 2%. That's all. If they can get 1 or 2%, they're happy. Improvement across that line. So that's another example where an academic partnership can help you with a bottoms-up kind of approach.
Let's do one more. Your choice.
Okay. Well, I answered the one on the snapshot and the playbook, so hopefully that answers that one now. Cautionary tales. Yes, they all end up in pilot purgatory. I mean, there's just, I would say our research has had, it's research. So, like the project we did with analog devices, we tried 5 different things, and they didn't all work. Some worked better. We would everything from autoencoders and deep learning to fairly simple methods. And I guess if there's a cautionary tale, it would be, if it's only a few % better, but it's a really complex approach, it's probably not worth it. So keep it simple. But if it gives you a 10 or 20 or 30% improvement, and it's in something that matters, then it's worth the complexity and the lack of explainability.
Great. Well, let's thank Bruce for this, the talk and the questions.